Okay, so good afternoon to everyone. Now, in the previous class, in the morning class, we have already started the discussion about the instructions classification and the three types of classification that we have said that based on functionality, we can divide we can use the instruction classification based on the byte length, we can do, and based on the addressing node, we can do. So these are the three types of classification of the instruction and we can perform. So first, one by one, we will see that what happens. First, we will see based on the functionality, then we will see the based on the byte length, and at last we will see the based on the addressing node. So first, start from the based on functionality. So based on functionality, there is a data transfer instruction. Now, basically, what is the data transfer instruction means that what is data transfer instruction? Now, data transfer instruction means these are the set of instruction used to transfer a copy of data from one address called the source to the another address called the destination, and without modifying the content of the source. That means the content that is present, we will do what? We will move it from the source to destination. And one thing is that we will move this data between two register. We will perform this operation between the two register. So example is what? That example we are discussing. That example move A comma B. So move A comma B means what? The content that B is what? B is our source. B is our source. So that means the content of the B will move to A. The content of the B will move to A. This is what that means. B is our destination register. Sorry, B is our source register. And A is what? A is our destination register. So the content of the B will move to A. And A and B are the two registers. So the first type is data transfer between the two registers. But it is not always that the data should be transferred between the two registers, because there may happen that the data is transferred between the register or a memory. But if the data is transferred between the two registers, then we will write this command mov a comma b, or this is what ab I have written. You can use anything also. You may write c or d, ef, gh, ij. You can write like that. But as an example, I have taken this name a and b, and this instruction is specifying that the data is transferred between the two registers. And this two register, what we have, A and B are the two register we have. Then next is what? Data transfer between the register and the memory. So that means data should be transferred between the register and the memory location. Or we can say from memory to our register, the data should be transferred from memory to register or from register to memory. That can happen in both way, it can happen. So first you see, in this case, we will write like that, LDA. Now, what is the meaning of this LDA? LD stands for load. LOAD, load. LD stands for load. And A is what we have already discussed. A means accumulator. A means accumulator. And this is what 9000H. This is what? This is a memory address. A memory address is written like that. In that way, in 16-bit, we can, this memory location means the memory address will be a hexadecimal code. This will be a hexadecimal code. So the memory address basically we write like that. So I have taken a memory location This memory address is what? This memory address is 9000H. So that means inside this memory location, the data that is stored will move to the register, because we know accumulator is also a register. Accumulator is also a register. That, if you remember, accumulator is the special type of register. So that means here the data is transferred between register and the memory location. That means the content or the data that is stored in this 9000H location will be transferred to the accumulator. That means the data should be loaded into the accumulator. That's why this command we write when our data is transferred between register and a memory. We only write LDA, load. In that case, we write load command, LDA. So that means now let's say in this 9000H memory location or the memory address which we have taken, inside it we have, let's say, a data 80H, the octal code like a data is stored there. So that means this 80H data will be moved to the accumulator. This is what for our discussion. If you remember, it is stored like RTL, register transfer language. We have written like that. Like we have written it like the register transfer language. That means from here we have written A. A is what? Accumulator, and there is an arrow given. You see, the arrow is given and 9000H. That means it will do what? The data will be moved to the accumulator, or we can say, for in this case, the data will be loaded into the accumulator. So that means for this, if the data is transferred between register and memory, then memory location, then we write like this. And for immediate data transfer, now it is not the case that always directly from memory location to the register or from register to register data can be transferred. It may happen that the immediate data transfer should be done. In that case, what and how we will write like that? In that case, we will use the command mvi. Mv means move. Mv means move, and I is means immediate data transfer. And here this is B. B is a register. We are taking a B register, and 08H is the data. Now here you see we didn't use any memory location. We didn't use any register also. Only directly we are writing the data, and this data will be moved into the register B. In that case, we will use this command. If any immediate data transfer should be done, then we will first write mvi, move immediate. It means move immediate. And in this left side, we will write a register name. The register in which you want to transfer, that register name should be mentioned, and a data should be there. A data should be present there. So that means this data will directly loaded into the register. So if we say the register transfer language, we can write like that. If we use the register transfer language, it will be written like that. Is what? This is the data. This is the data, octal data, which we have. We are directly loading this data into the register B. There is nothing like that, this transfer is between register to register or register to memory. This transfer is directly happening. So if like this we have to perform any immediate data transfer, then we will use the command mvi, and a register, destination register should be mentioned, and the data, particular data you want to move, that particular data should be written. And fourth case is what? Fourth case is the if data should be transferred between input output device and the accumulator. If data should be transferred between input output device and the accumulator, then we will write in port 1. Now if we write this command in port 1 or out port 2, that means what? From port 1, the data will be loaded into the accumulator. Now if nothing is mentioned, then we always think that it will be loaded or move or anything, it will be on the accumulator. That means those operations will be performed over the accumulator. So that's why if nothing is mentioned, always remember that it will be over the accumulator if nothing is mentioned. That is why if in port 1, that means from port 1 the data is loaded into the accumulator, or out port 2 from accumulator, from ports 0 it will be going to the accumulator. So like this the data transfer will be done for the input output device and the accumulator. So these are of the 4 types, and this is what data transfer instruction. Now if you see all the cases, in all the case there is the same link, that is data is transferred. Main thing what is happening, data is transferred. Now data is transferred between register to register, data is transferred between memory location and the register, data is transferred immediately, or the data is transferred between input output device and the accumulator. So all these cases has same thing, that main thing is what? Data is transferring. So this is what the data transfer instruction says. Okay, clear to everyone? It is clear? It is clear? Then I will move to the next part.
Yes, sir.
Yes, sir.
Okay. So the next is for the arithmetic instruction. Now for arithmetic instruction, here what happens for the arithmetic instruction? This is a state of instruction perform all the arithmetic operation of the microprocessor. Operation should be there, addition, subtraction, multiplication, division, all of the thing will be there for the arithmetic instructions case. Now addition is what? In the addition, any 8-bit data or the content of any register or the content of any memory address will be added with the content of the accumulator, and after the performing the operation it will be stored into the accumulator again. Now let's say an example is given. Let's say we have an example given ADDB. That means add B we have given. That means what? The data that is stored into the B, the data that is stored into the B register will be added with the content of the accumulator, and after adding the final result will be all again stored into the accumulator again. So that means if it is written like that ADDB, that means the content that is present inside the B register will be added with the content of the accumulator. Content of the accumulator, it will be added, and the final product which we get will be on the stored onto the accumulator again. Now here also for addition case also, you see we have this command ADI08H. Now I have already mentioned I means if any I is given, that means it is immediate. I is given, that is immediate. That means here you see ADI means addition immediate. That means this 08H, in this 08H is the data. This data will be added with the content of the accumulator, and after that it will be stored into the accumulator again. So that's why here I is mentioned. I is mentioned for what? Immediate. Immediate case, then we mention the I. In the data transfer also we have seen that if we are here we have used MVI, so immediate, I means immediate. So that means here also ADI, you see this command we have used ADI 08H. That means this 08H is the data, and this data we directly adding with the content of the accumulator. This 08H data we are adding with the content of the accumulator immediately. So that's why what, and after that the final product will be stored into the accumulator again. So this is the command suggest. Then we will see the subtraction. Subtractions also has like that procedure, that if the subtraction procedure is done using the 2's complement method. That means if we mention like that, if this is we mentioned sub d, that means what, the content, the content that is present in the d, the content that is present in the d register will be subtracted from the content that is stored into the accumulator. With that, the subtractions will be performed, and the product or the result we get will be stored into the accumulator again. So this is the same as that for addition, like that subtraction is there, and multiplication, division, there is also same procedure. For multiplication we will use the mult, for division we will use the div. This command we use, so same procedure like that. So that's why I not mentioned, but that procedure is also there. And that is what it is, the increment decrement. There is what increment decrement is also an arithmetic operation. So if this type of instructions will be there, that if the content of the 8-bit or the 16-bit register pair will be either incremented or decremented. Now through example, if we see through example, then it will be clear that what I am saying, that let's say this is what we have mentioned, INRB. INRB, that means increment B, content of the B register. INRB means what? Increment the content of the B register with only increment. How much it will be increment? The content of the B that is present will be incremented 1. So INRB we will write, that means this will perform like that, that the content of the B in the B register, the value or the data that is stored will be incremented 1 value, and it will be stored into the B again. And if we use the register pair means 2 registers will be combined. Register pair means 2 register will be combined. And in that case, what we will write? In this case, we will write X. INX. X means register pair. X means register pair. Now, here we are writing INXD. So the register pair, how we will choose the register pair? Now, if here we have used D, here we have used D. So that's why it is, that's next letter we are choosing DE. Now, if we use here A, in that means in that case, what will happen? If we, let's say in this we didn't use that and we use A, then that time it will be B, AB plus 1, AB plus 1. That means register pair, the next register, and combining them, we are saying that they are the register pair. Now here I have used the D, we have choose the D, so that's why I am register pair is DE. That means the content in the DE register pair, the content that is stored into the D register pair will be incremented with 1, and it will be stored into the D register again. Same as that for decrement, we use DCR for if there is a single register. If there is a single register, then we use the DCR. But if it is a register pair, in that case we will use the DCX, because X means what? If it X, then it is the register pair. So same as that, B, the content of the B, if we use DCRB, that means the content of the B, that is the value that is stored there, will be decremented with 1, will be decremented 1, and it will be stored into the B again. And if we use the DCX, if use the DCX, that means the register pair. So DE, and the content that is present inside this register pair will be decremented by 1, and it will be stored into the D register again. So this is what the increment and decrement operation. Now another also is there present, that is the logical instruction. Logical instruction is basically what? This is the set of instruction will perform the logical operation with the content of the accumulator. That means with the content of the accumulator, the logical operations should be performed. Now logical operations, we already know that it will be AND or XOR, that will be there. For another, comparing will also be there. So if AND or XOR, in that case, let's say for AND or XOR operation, in this, let's say we have like register A, we have like register A, and we have register B. That means between these two register, or operations will be performed, and the final result will be stored into the register A, that means accumulator. A, we are defining always a register, we define as the accumulator. So that means here we have already mentioned that the set of instruction will perform the logical operation with the content of the accumulator. With the content of the accumulator, the operations will be performed. So that means what? That means the content that is stored into the accumulator will perform OR operation with the content that is stored into the our B register, and the result will be what? The result will be stored into the accumulator again. Now this is OR. Here it can happen AND, here it can happen XOR, here it can happen NOT operations, then everything, every logical operations we can able to perform here. And if it is compare, then in that case we will write the command like this, CMPB. For if it is OR operation, then we will write like that, OR B. If it is AND operation, then let's say we are performing AND operation, then we will write the command and the register with whom the accumulator AND operations will be performed. Let's say we are let's say and C, we written like and C. That means the accumulator, that means the accumulator with this and operation, and the register we choose, that is the C, and the result we will get will be stored into the accumulator again. So this is what, this is the thing. In that case, if it is XOR, then we'll write the XOR. If it is NOT operations, then we'll write the NOT. So that is what, if you use anything, this is what the AND or XOR operations are performed. The another logical operations, that is the compare. Compare is another logical operations. So what we'll write for the comparison? In this comparison, we will write the statement or the instruction as CMPB. CMP, sorry, B is what? B, I have the register I mentioned. You may use anything. It depends upon you. It may you use anything. But in this case, I have used B. And we'll what? We'll write this CMP. When we will write this command CMP, that means what? Compare. We will be able to know that CMP means what? It will be compare operation. So comparison will be done. Now here we have mentioned CMPB. That means the comparison will be done between the data that is stored into the accumulator and the data that is stored into the register B, because here I have mentioned register B. So that means comparison. So there will be three cases. That means if the two data are same, so if there will be the three cases that two data may be same, or either the data or the value that is stored into the accumulator will be greater than the value or the data that is stored into the other register, or the negative or the positive. This is the thing that it may happen, that the data that is stored into the accumulator is much more than the data value that is stored into the register B. In that case, what will happen? We will get any positive value. But if the data that is stored into the accumulator is less than the data that is stored into the B register, then we will get what? Then we will get the result as the negative. So this is what is that there may be happening that in the accumulator and the B register are equal, or the sign bit equal to 1. In that case, the accumulator value is greater than accumulator value is greater than, and the other case that if we get the negative, in that case, that is what, in that case, if the accumulator value is negative, then in that case the sign bit will be 1, and the we can say this B, the B register value, if let's say this will happen that the we will get the result as a negative. Let's say we will get the result as a negative. In negative means what? We know that the sign bit will be 1, and that means what? The data that is stored into the B register is greater than the data that is stored into the accumulator. In that case, we will get the negative result. And if the data that is stored into the accumulator is greater than the data that is stored into the register B, in that case we will get the positive result. So this is the three types of comparison. So this is the comparison, and this is also we done for the arithmetic instructions operation. So this is what for the arithmetic instructions, for case of arithmetic instructions we perform. Okay, so this is what, this is the next type, that is the arithmetic instruction case. Now we will see the third type, that is the rotate. Now what is rotate? Rotate is the value of the accumulator will be shifted either to the left or to the right by 1 bit. Now if you remember, shifting I have done when I have discussed the Booth's multiplication. In that case, in the Booth's multiplication case, in the restoring division, that time we are performing the shifting, left shift, right shift. If you remember that type of shifting, either it can shift left or either it can shift right, but only 1 bit can be shifted. This is what, only 1 bit will be shifted either to left or either to right. Then fourth is the complement. Now complement is what? The content of the accumulator will be complemented. The content of the accumulator will be complemented. That means if the accumulator has the value 0, then it will be 1, that it will be 1, or if the value that is stored into the accumulator, let's say there is 1, then it will be 0. So that is what complementing. This is the complementer. And the last type, or that is the branching instruction. Branching instruction is the set of instruction that alters the sequence of program execution, either condition or unconditionally. Either conditionally or unconditionally, it will do what? It will alter the sequence of the program execution. So let's say we have the first thing, that is the jump. The jump. So what is the jump? Jump is the conditional jumps are important aspect of the decision making process in a programming. This instruction check for the certain condition and alter the sequence when the condition is made. The instruction set also includes some unconditional jump operation. So let's say this is our total instruction is written like that this is the address and this is the statements we have. So this is a memory location. In this left side, we are using the memory location. Now let's say we're starting from the first 8000H memory location. Now in this 8000H memory location, the first command it is, or the instruction it is given that mvi b, 08H. So this instruction is present in the 8000H. So already from here we can say that means 08H data will be moved to the B, will be moved to the register B. Then next is what 8002H. 8002H in this memory location, the next instruction is written that is ADDB. That means now in B, what value is there? In B, we already moved the data. So 08H is moved to the B. So that means this 08H, which is in the register B, will be added with the content of the accumulator. Here we do not have anything mentioned. That means the content with the content of the accumulator, this 08H will be added. Now in the next memory address 8003H, in this memory address, the next instruction it is written MVIC, 11H. So that means immediate addressing. Immediate addressing is what? Immediate data transfer. Here it is immediate MVIC. So that means immediate data transfer should be done. So 11H, this will be moved to the C register. This data will be moved to the C register. Okay. So then after that, the next instruction is what? 8005H in this memory location, sub C. That means now in the content of the C, what is the value? The content of the C contains 11H. This data is containing by the C register now. That means this data will be what? We will subtract it from the accumulator data, because sub C, so there is what? We have to perform the operations from the accumulator. If nothing is mentioned, that means the content that is stored into the accumulator, from there the subtraction operations will be performed with the C register, and in this C register we have the value 11H. That means content of the accumulator, the value that is there, from there the 11H should be subtracted, because in C now 11H data is stored. After that, we have 8006H in this memory location, STA 9500H. Now 9500H is what? This is a memory location. This is another memory location. And this memory location, we are saying that stored into the accumulator. STA means stored into the accumulator. So this 9500H memory location. Now that means what? In this memory location, the data is stored, will be stored into the accumulator now. And after that, the instruction is in the 8008H memory location, JMP 8002H. So this means what? JMP condition or the JMP instruction means jump. So jump to the 8002H memory location again. So that means this next instruction will not be executed. From there, the jump will occur from 8008 memory location again, because here in this 8008 memory location, what instruction is present? JMP 8002H. That means this instruction saying that again jump to that memory location. So again from 8008, after executing the instruction, this will again jump into the 8002 memory location, and again this instructions will be executed. So this will be continued, and this last instruction that is on the 800AH memory location, we have another instruction that is HLT. HLT means what? HLT means halt. So this halt instruction will not be executed, because every time it came and it is saying again jump into that memory location. That means this portion, the execution will not able to come, because every time this will came here and from there it will be said jump to that memory location. So this will be executed as a loop more than one times or thousand of times. So this instruction will not be executed. And HLT means what? HLT means halt, means stop the program. So this is what the jump instruction. Okay, clear to everyone till now?
Yes, sir.
Yes, sir.
Okay, so there is other instructions, because the time it is very less. So I will the other instructions, the based on the byte length and based on the addressing node, I will discuss in the next class. So that thing I know that it is left, but we have to each and every instruction, this instructions thing you have to keep in mind. That's why I am not going so fast, because these are the instruction you should remember and what are the purpose and why we are using this. So that's why I will go slowly. Then I will cover each and every instruction for that, and these instructions are necessary. So I will give total a list of instruction there. So the list of instruction, when the class will go on, you will see the list of instructions, and that will be then one by one instructions I will explain like that. Okay, so then in the next class I think we have the class in the Saturday. So in Saturday I will again try to take 2 classes so that these things should be covered. So today this much. So thank you everyone. I am ending
Thank
the
Thank you,
you,
sir.
session
sir.
then. Okay.